Welcome to the Innovators Playbook podcast. I am your host, Seth Narayanan, founder and CEO of Telient Systems. Each week, I'll be sitting down with entrepreneurs, product leaders, and technologists who are solving real world problems with bold ideas and smart execution. We will dig into what is working, what's not, and the lessons they have learned turning vision into reality. If you're leading digital transformation, scaling a startup, or just curious how innovation really happens behind the scenes, this is your playbook. Let's get started. Welcome to the Innovators Playbook podcast. I'm your host, Seth Narayanan, founder and CEO of Telient Systems. Today, I'm honored to have Patrick Hill join us. Patrick serves as the Chief Technology Officer at Mott Corporation, a leader in precision filtration and flow control. With over 2 decades in engineering, Patrick has been instrumental in pioneering sustainable water treatment technologies. Under his leadership, Mott has tackled complex challenges such as treating millions of gallons of agricultural wastewater daily, showcasing innovative approaches for environmental sustainability. Beyond his technical expertise, Patrick is passionate about aligning engineering solutions with real-world environmental needs, making a tangible impact on industries and communities alike. Patrick, welcome to the Innovators Playbook podcast. It's a pleasure to have you.
Good afternoon, Seth. Thanks for arranging this and looking forward to a great talk today.
You've had a very impressive journey in your career, starting out as an engineer, becoming a manager, director, all the way to a CTO role right now. Can you share with the listeners what made this journey possible?
It's certainly been a wild ride. I feel every year or a year and a half, I'm lucky enough to be able to do something new. Reflecting upon this, I actually had an interview candidate just a half hour ago ask me this same question. So there's really 3 key things to talk about. The first is any person who wants to grow in their career has to have drive. You have to want to learn and grow. My personal philosophy is if I'm ever in a role where I'm not learning, that's just not interesting to me. That's not a place where I want to be. And most of the roles that I've taken with only, say, 75% of the necessary experience and was willing to stretch into the rest. The second thing is I think engineers in particular would benefit a lot from viewing their job description as a dotted line or very fuzzy box rather than a rigid box. Too often, we fall into the trap of staying within the box of what we're told to do or what we might be here to do. And growth happens outside the box. And in this case, that could be gaining experience on the manufacturing floor or working with your finance business partner on some financial data analysis to learn more about that aspect of the business, or maybe even participating in extra interviews elsewhere in the business to practice your ability to interface with new candidates. All of these things result in additional growth and something that I've done a lot in my career and I always do, especially when it's in the best interest of helping achieve a company objective. This third one's really important, Seth. You have to have a manager who is willing to stretch you, a leader who is willing to mentor you and give you a chance. I was very fortunate in my time at Mott. My manager for most of my time, Boris Levin, the former CEO. Boris has taken a new job within IDEC post our acquisition now. But Boris was always great at, number one, pushing me to be better. He did it in a way where he was resolute on his expectations, but always caring of my needs. He was also willing to stretch me into something new when I wasn't quite ready, because at the end of the day, he believed in me. That's a leadership principle that I've taken to my teams. It's something I think in the industry we could benefit a lot more from seeing. A little bit less on the annual goals, a little bit more on how do we stretch folks to do something that they didn't think they could do. You might be surprised at some of the outcomes you can get handling it that way.
Yeah, excellent. You mentioned a few key things there, but before I ask you a follow-up on that, I want to dive back a little bit. If I recall right, you went to school for mechanical engineering.
I did, yes.
That kind of caught my attention. In today's world, that is not something that people generally gravitate toward. There are so many other flashy things. What got you interested in that?
Mechanical engineering, I think, is the base of problem solving. Most things we do on a daily basis, you would benefit from understanding the mechanical systems within them. Personally, I'm very interested in cars and automobiles and building and driving and racing cars and automobiles. For me, it was a little more of a natural fit, but I also think mechanical engineering as a degree is very versatile and flexible. You can span industries, markets, industry trends. You may not necessarily have the specialty of a software engineer or a biomedical engineer or something of this nature, robotics engineer nowadays, but it's a very flexible degree that teaches you a lot about problem solving and understanding the basic engineering principles.
Very interesting. No, it's good that you had that interest and you've made a career in that. A lot of people pivot at various points. I got a degree in electrical engineering, but pivoted to computers right from day one.
Mhm.
Sometimes I do miss not having pursued a career there, but good for you. Talking about mechanical engineering and hardware, and especially around AI and data center, I know those are some of the things that you guys work with. What does innovation look like when you're solving problems like that? What is happening now with AI and the need for data centers and cooling and all that stuff? How are you guys involved in that?
AIs and data centers, rapidly expanding market, absolutely critical to the backbone of our society as the use of artificial intelligence becomes more and more widespread. The single word that answers your question, Seth, is size. Interestingly, the size perspective varies depending on where you look. In the case of energy production or water to cool data centers, we're talking about larger systems than we've ever seen before, higher flow rates, better cooling capacities, higher power generation. So we're talking about larger size. Within the towers or server racks themselves, size plays the opposite role, where we are being tasked to design something smaller but higher performing than ever before. In this case, that could be a cooling plate for a server rack that helps thermally manage all the heat that's being produced. As folks play around with ChatGPT and Gemini, that becomes more proliferated in the world. But size is really the key element, and that creates engineering challenges on both ends as well. It's been a ton of fun so far. We're now talking on the water side about millions of gallons a day passing through and cooling. When you design a system to handle that, what you translate on paper and what comes out in reality, the scale can surprise you.
Yeah, quick sidebar on that. That water that you use to cool, does that get recycled?
It does. Depends on the specific data center design. So some use a closed loop system where the water behaves more like a refrigerant in your refrigerator or other sort of air conditioning device. Some use a single pass system where they'll take water out of a freshwater source, cool it through, and place it right back in that freshwater source with a couple degree rise in temperature. Some use direct air cooling, really depends on the data center, but in most cases, that's not water that's being wasted in some way, shape, or form. It's being used for its thermal energy and then placed right back in the environment so we can still have access to it.
Interesting. I talk a lot about AI, and you probably do as well from the software side, solving the AI question or problem from hardware side and what is needed to support that, such as energy consumption. And what sort of innovations are playing a role in making AI more sustainable? I just read that a couple of weeks ago that Meta has signed like some humongous deal with the power supplier for 10 years, right? I've heard about whole towns in Texas, their power being taken up by Tesla and so on. Where do you see innovation helping that?
Yeah, two areas. Power is certainly one of them. The power grab, so to speak, that's happening right now with large scale data centers is extreme. I read a few articles about this over the last few months. An AI-based search, a ChatGPT query or something similar, demands 10 to 15 times the electrical consumption or electrical energy as a simple Google search of your favorite restaurant. As we use that more, which we certainly are more than ever, the demand for base load electrical power is rising quite fast. That's both good and bad. For folks like you and I and our electric bills, it's not the greatest. Let's be honest. From the technology perspective, how to get more power out into the grid is a really interesting problem to solve. Every major domestic AI company has partnered in some way with a stable multi-year, multi-decade utility company. Most of them are nuclear power. Interestingly, I think nuclear power is a really smart choice here. It's got a very, very low carbon intensity, almost none. It's a phenomenal base load power. It's not susceptible to weather conditions or sunlight, lack of wind, any sort of rising or changing water events. It's got incredibly high uptime. When you think about what a data center needs, checks all the boxes. Our role in that is how can we help those nuclear power suppliers accelerate the eventual deployment of both small scale and large scale nuclear reactors. In the small scale side, we play mostly in gas filtration, where we're removing solid particles from gas streams, whether that's environmental control within the system or some specialty services such as that. On the large scale side, we do a little bit in gas filtration, but a lot more in the water filtration side, where again, we're making sure that water that's passing through the nuclear reactor, whether it's primary, secondary, or third loop, depending on the design, is the right inlet spec and maintains the right purity level. The second topic, Seth, sorry, I'm talking about this a lot. This is where I get a lot of the second topic I already mentioned, which is cooling plates on the server racks themselves. How do you keep those individual servers cool? This is where Mott's additive 3D printing technology really shines. And we're able to print a thermal transfer device, effectively a heat exchanger, with such incredibly unique geometries that can't be conventionally manufactured. When we think of this scale and size problem that I mentioned before, additive and 3D printing is a great way to break that mold and do something more than what conventional can currently give us, and ultimately lead to the next layer of advancement for those data centers.
Interesting. If I can follow up on that, you said 3D printing is a better solution than maybe mass manufacturing. Is that because the designs are very custom for each application and where you have to custom design the plates and the cooling fins that are needed? Is that what you're talking about?
That's correct. With additive technology, you can achieve a design that you just simply can't in conventional manufacturing. So I'll give an example that's unrelated to AI, but just statistically, we had an aerospace customer uses our filter to filter rocket fuel. They've been buying a conventional filter for quite a while. It's roughly the size of a cell phone. They needed to triple their flow rate, or therefore triple their filtration area. The challenge is it's a highly integrated system that they're working on. My default would be to make my filter 3 times bigger. If you need 3 times the area, the size of my filter is simply going to be 3 times bigger. Can't do that here. We need to launch this thing to outer space. We need to maintain a weight limit. We need to maintain an envelope because there are other components and devices nearby. That's a problem where we were able to translate from conventional manufacturing to additive. By using additive, we were able to get that 3x increase in filter area by printing a design that we could not conventionally manufacture. Additional surface area, fins, things of that nature. It's that kind of mold breaking that I'm talking about here, in specific to the cooling plates. 3D printing, in full transparency, has its drawbacks, like you point out. It is not the highest volume manufacturing method, and so you need to be specific on how it's deployed. And this is a good use case of how it's deployed, something that lasts for a while, it's reusable, and it's achieving a performance factor that you simply can't get any other way.
Yeah, it's interesting that filtration and purification systems don't sound like cutting edge technologies, but here you are using cutting edge 3D printing technology to do that. Plus, I'm assuming there is also a lot on the material science side of things that you guys are using innovation or getting innovation around that.
On material science in particular, in a way, Seth, you are right. There are plenty of filters in the world that are fairly straightforward and fairly simple. Those are important. The oil filter in your car is very important. Without it, bad things happen.
I can remember one time we forgot to change our air conditioning filter for what seemed like maybe a couple of years. And what we got out of that was, geez.
That's right. Are they highly engineered nowadays? No, it's a mature product that's existed for a long time. But there are so many places in the filtration and flow control space that the consequence of not having that highly engineered device is consequential, just extreme in some cases. I'll give you a few examples. In our healthcare business, we make a part the size of a grain of salt in your hand. 9 times out of 10, you'll look down and not even know it's there. This particular part helps diffuse medication to patients over the period of many months. Very specific flow tolerance. You can imagine if we don't diffuse enough medication, that's a problem. If we diffuse too much medication, that's also a problem. To have something that small have such a highly engineered flow specification, still to this day, 8 years later, blows my mind. It really does. In the oil and gas sector, we remove catalyst from oil and gas streams that eventually get turned into things like diesel fuel. One day of our filter not operating results in hundreds of thousands of dollars of lost product revenue. In the semiconductor space, we talked a little bit about the cooling chips, but in traditional gas filtration, we're separating particles down to 1.5 nanometer in size, completely undetectable by the human eye, several orders of magnitude lower than what the human eye can possibly detect. We're separating them to a purity level called 9 log, which is 99 point, and then 7 decimal places after, or 7 nines after the decimal place, for a total of 9 level of purity. That's the equivalent, Seth, of capturing every drop of water off of Niagara Falls in a 24-hour period, except for one drop. So you're right. The innovation and science that goes into something like that, a lot of thought, a lot of testing, but man, the applications that result are truly amazing.
Yeah, for anybody that would assume that there is not innovation there, you just schooled us on that. So one question that popped my head is you obviously operate in a whole variety of industries, right? From semiconductors to aerospace to oil and gas and so on. When you create new products, are they cross industry and cross functional to begin with? Do you have to do things to make them that way? How do you manage that?
We have one key backbone to all of our products, and that is porous material of some kind, usually metal, a little bit in ceramics and polymers. But we use that porous material to achieve filtration, flow control, and diffusion. But the products are usually very customer specific, not even market or application specific, but what this particular customer needs from a flow rate, or drop, temperature, pressure, particle size removal perspective. We have over 40,000 active solutions out in the marketplace. We design on average another 2 solutions every day. These are highly customized to what our customers need. At the end of the day, our customers, Fortune 500, some of the best and most innovative brands in the world, they need something catered to exactly how their process works. And that's what we look to provide.
Very cool. We have talked quite a bit about technology, which is controllable and manageable for the most part. Coming to people, and you mentioned how your boss mentored you. Talk a little bit about how do you coach people that work in your teams, and especially now with AI coming up, how do you bring that knowledge to bear in your business and train them and stay competitive and cutting edge in your role?
That's a great question. I mentioned at the beginning, what I value is growth. One of the key questions I ask my employees is, how are you growing or where do you want to grow? As it relates to AI, the question we're currently asking is, how many AI coworkers can you have? And I think it's a really important topic to think about. Certainly read headlines of AI will replace job XYZ or use AI to create your own startup company. But as a coworker, AI can be so incredibly powerful. I had an example of a filtration scientist the other day that was running a customer sample, looking to achieve efficacy of that design. With AI, they were able to produce their final lab report 10 times faster than if they wrote it themselves. Now, this is a person that's written thousands of these. They know how to do it. And even with that experience, armed with an AI coworker, they achieved performance that I think anyone would have thought was unachievable otherwise. And so that's the key fundamental question we're asking. How many AI coworkers can you have?
Good question. In the pure software world, junior software engineers, especially people that are coming into the business, are being sorely threatened because the easiest role that AI can replace is a junior or mid-level software engineer. The higher you get, if you get into an architect level, I don't think we have AI tools right now that can architect an entire system. In fact, I read a recent report that said senior engineers and architects actually feel that AI is taking time away from them because by the time they build individual pieces and put it together and make it work together, they feel like that's actually a loss of productivity. But in your role as filtration scientists or mechanical engineers or other engineers, when you have these agents, do you see them maybe a junior employee that is working with you guys, or do you see them performing more advanced roles possibly soon?
Today, I think it's more on the process optimization side. And so, yes, a little more on the junior scope of work, I think is fair. But we are only months into this in the grand scheme of things. So I am certain in the future, as the learning models continue to get implemented, I feel like there's a new release every couple weeks now. I am certain our ability to use AI and higher capacities will only increase. The advice that I've been given that I would also like to share is how can you think about breaking down and reinventing an entire business process to use AI as a backbone? We often find places where we use AI for quick efficiency gains. I gave one example of that. Where do we have an entire business process that we can rewrite with this kind of mindset? That's the level of thinking I think is coming next, and certainly something we're excited about at Mott.
From a team building perspective, I know you mentioned that truly learning is important to grow a team. What other wisdom do you have in how you manage cross-functional teams, especially when they are working across hardware, software, various industries? Do you have any learnings around that?
Yeah, my advice can be summarized in 2 words: intentional diversity. I think the best team is one that is built with intentional diversity in skill and thought. It can create difference of opinions sometimes, but typically those differences of opinions foster a more creative environment, an environment where more solutions are explored, and ultimately an environment that drives better product result than several like-minded folks trying to solve a problem. So intentional diversity is my answer there. It's something I will always stick to. It's something I've talked to my people leaders about to make sure that within each of their teams, we have a diverse range of skills.
Very interesting. I don't know if I have come across that phrase. You may have to copyright that.
I'll work on that right now. Thanks.
I know Mott is doing something to spur innovation. You have something called the Mott Minute series, right? What is that? Tell me a little bit about that.
So we're having a lot of fun with the Mott Minute series. We just launched it a few weeks ago. It is intended to give our customers and prospective customers a 1 minute or less glance into a particular product, solution, or problem in the marketplace and how we may be positioned to help. It also helps highlight some of the innovative minds that we have within our company who solve, again, truly world-class, life-changing problems. And prepping for those has been a lot of fun. I talk about engineering for a living. It's something I'm quite comfortable with, but there are plenty of engineers who don't. And to also see them grow in this way has been a lot of fun so far. I think we've done 4 videos. For folks that are listening, we have another 6 or 7 recorded, ready to go. And we look forward to releasing these once a week for as long as we possibly can.
Wow. I think that's a great idea. Like you said, not just showcasing the actual work that's being done, but also the people that are doing it, giving them a stage, showcasing them and bringing them out. It all helps foster that innovative spirit within the company. That's great.
I agree with you. And the third benefit is it keeps us connected to the problems that we're solving. Sometimes as engineers, you forget about the problem and you just look at the drawing or the list of technical requirements, and your mind focuses on how do you get the drawing built or how do you get the technical requirements satisfied. You forget the world's problem that you're trying to solve, whether it's that oil refinery, that patient who needs that medical device, or anything else in between.
Patrick, you've done a lot of podcasts before. So, from your vantage point, there's a lot of talk about AI and stuff like that. But do you have anything that you think needs more attention?
I really do think this conversation of power demand, specifically in the United States, also in Europe, for the record, same problem exists there. This conversation of power demand could use some better visibility. We may also turn to power sources that might not be very good for us in the long run. That portion could use a little more focus. Previous to Mott, I did spend nearly a decade in commercial nuclear power. It's a field I'm still very passionate about. I do think that's the right answer here, but nuclear power takes a long time. Even a small modular reactor takes years and years to license and build and commission. We don't have that kind of time scale here. Something will give if we don't solve it faster than that.
Very interesting. As a electrical engineer, I was always interested in the power generation aspects of that field. I agree with you that AI, at this point, I'm almost going to call it abuse of power. I don't know if it's going to be justifiable. I think one of the things that, in my opinion, is going to put the brakes on it is people have tallied up the cost benefit of the AI solutions that are out there. For example, if I do a Google search on something, right? By default, it's including an AI overview. It
Right.
used to be just the search results. And I don't know what the cost of that is, right? How is Google paying for it? Because people are not paying more. I don't know if they're maybe making it up in per keyword click that they are getting from the advertisers. But I feel like at some point the chickens are going to come home to roost. Accountants are going to get involved and tally up the cost versus benefit. I mean, I agree that power consumption globally will continue to go up even without AI because there's more people. I come from India, and India does not have the amount of power distribution that a modern country like United States has. So there are a lot of people that need power in India for basic needs, right? And that needs to grow, and we need to find technologies to do. And I'm very curious and interested in, other than nuclear, what else might be out there to generate power. But I do think this AI thing hopefully gets solved in other ways than just throwing tons more power, gigawatts more power at it.
I agree with you. I think this is where we got to drive some level of innovation to change that curve. I fundamentally think that it'll be interesting. I will say on the Google AI summary, I have found myself defaulting to whatever that summary says more often.
Yeah, I do too. I don't even look at.
Every time I Google something.
Yeah, it is so good. It just summarizes everything so that I don't have to read up 10 articles to form the opinion. But I do wonder sometimes if that's the best answer. We have to trust it.
I agree with you.
So if we zoom out in the next 5 to 10 years, what do you see coming in the fields that you are in and maybe even generally in technology?
Yeah, I think we have to solve that size and scale problem. It doesn't really matter which field you pick. There's macro size problems to solve and micro size. In the semiconductor industry, for example, we're currently making 3 nanometer node features right now. The typical rule of thumb is I've got to capture particles smaller than that to make sure that those processes remain of high integrity and purity. Though as computing power increases, it's just inevitable that those node features will continue to get smaller and smaller. That places a scale and size problem, on my team on how to innovate to stay on or ahead of that curve if possible. Similar challenge in the med device space as we start to transition a bit more towards quote unquote boutique drug manufacturing, the ability to go small and pivot is going to be important. In the energy sector, it's normally on the larger end. How can you solve these large, complex, integrated energy problems? One field we didn't talk about today is the production of green hydrogen via electrolysis. It's a market we really enjoy playing in. We make a component called a porous transport layer, which is essential to that separation of that water molecule and the production of hydrogen. Those systems are starting to be produced on a scale larger than anyone has ever seen before. And so that translates back to that size and scale problem within our internal product development and try to solve. That's the one broad theme. It's been a theme in the past. I think it's an inevitable truth and it will continue to be a theme in the future.
Very interesting. I've been hoping that some other technology like that will come in place. Hydrogen fuel cell is something that I used to hear about that I don't hear that anymore. One final question I'd like to know from leaders like you is what advice do you have for younger people that are in high school, maybe in college or starting their careers, especially in technology?
I think stay hungry, always being willing to do more, find more, solve more problems is important. And like I mentioned in that very first question, Seth, be willing to go outside the line for the common good, not just intentionally to be distracting. But if your
Yeah.
team needs help and it's outside your lines and you're capable of helping, find a way to help. You'll learn something new, you'll grow, your team will benefit from that result. Those are two key bits of advice I would give.
Excellent. Patrick, it's been a pleasure. Thank you for taking the time, and I really appreciate what you have shared here. I'm sure people would benefit from this.
Thank you, Seth. I had a great time, amazing conversation, and I hope you have a great rest of the day. Thanks again.